Welcome back to the Massive Loop tutorial series. Today we're going to go over tutorial number 3, Intro to Scripting. And this will be our first dive into actually programming worlds using the Massive Loop SDK. This tutorial takes about 30 minutes to complete. And in it, we're going to build this simple first-person virtual reality shooter that I call Target Practice. In Target Practice, a player can run around this paintball arena where there are random dummy targets spawning. And as we hit them, we'll want to keep track of the player's score. For this tutorial, it will be much easier if you've already had at least some Unity programming experience, because a lot of the concepts will be used here. If you haven't watched the first two tutorials, I highly recommend you do. They only take about 20 minutes combined, and it will teach you the basics of creating a world without scripting, and what out-of-the-box Unity features you can use to make your Massive Loop worlds even more interesting. The Massive Loop SDK uses the Lua programming language. Lua is a fast, lightweight language that is very capable and very quick to learn. Lua supports complex data types like dictionaries and objects, and Lua is also commonly used in game development, making it a solid choice for our SDK. We have intentionally made the Massive Loop SDK resemble syntax that you are familiar with from Unity C# programming. So if you're a Unity programmer, you'll find that translating what you already know from Unity to Massive Loop Lua is really very simple. This is an example of a script that fires a bullet from a tank. The first line instantiates the bullet. The second line grabs the rigid body component. The third line then uses the rigid body to add force and fire the bullet. Now here's how we translate that code into Lua for the Massive Loop SDK. Again, we instantiate the bullet, grab the rigid body, and then finally, we use the rigid body to add force and fire the bullet. You'll notice the structure of the statements, as well as their parameters, are pretty much identical. If you're new to Lua and looking for a good reference on it, I highly recommend the book Lua Quick Start Guide by Gabor Sawyer. It covers Lua in depth, and you can easily read it in a single afternoon. Or if you want a quicker overview, you should consider watching our supplemental video called C# to Massive Loop Lua. This is a 10-minute tutorial meant to give Unity C# developers a very quick understanding of Massive Loop Lua syntax. The Massive Loop SDK is being updated frequently. You can always find the complete up-to-date reference document at sdk.massiveloop.com. Additional help can also be found here at massiveloop.com/SDK-tutorials, where we post short video tutorials like this one. Another great place to get help is at the SDK channels in our Discord server, where you can ask community members for help with scripting examples that you might be having trouble with. Let's quickly browse through the SDK reference at sdk.massiveloop.com. The Getting Started tab explains how to install the necessary software and set up your development environment so that you can build Massive Loop worlds. It also has links to a few Lua tutorials. The Scripting tab gives a brief overview of scripting concepts, like how to import scripts to make libraries, or using serialized fields or coroutines. The API reference tab is what we really want to look at. This is the complete reference of all implemented objects and features that you can use in Massive Loop Lua. If you're familiar with game development, you will see a lot of familiar items here that you can work with, such as colliders, the debug object, game objects, events, quaternions, ray casting, grab functionality, vectors, and more. We also have a Components tab with an overview of which components comprise the Massive Loop SDK and also third-party components as well. The Tutorials tab contains some additional tutorials beyond these video tutorials that can help get you started. A good way to think about the SDK is that it provides a wrapper or a single programming interface around everything you need to program your Massive Loop world. This includes Massive Loop features like multiplayer, variable synchronization, wallet operations, grab functionality, contacts, and more. Game engine features like physics, lighting, rigid bodies, and even third-party features which include components and APIs that we have integrated into Massive Loop worlds. One last thing I should mention before we start building our example is the importance of user security. Users must be able to download worlds from the metaverse and run them with confidence, knowing that their system and files are safe. That is why Massive Loop worlds do not allow any Unity C# scripting. Also, the Massive Loop SDK is run in a sandboxed environment. The sandboxed environment prevents scripts from accessing the user's local files and resources. A good way to think about this and why it's important is to compare it to a web browser, which we're all familiar with. Web browsers run a lightweight, capable scripting language called JavaScript, which is sandboxed to prevent it from accessing local files when you download a website. Without it being sandboxed, these JavaScript programs could access a user's local system and cause damage. Similar to that, the Massive Loop Metaverse browser runs a sandbox version of Lua, which is also a capable and lightweight language, and like JavaScript is prevented from accessing a user's local files and resources. So now that we're done with this overview, let's open up Unity and an editor and start scripting. Here I've opened up a completed version of the game so we can take a look at its general layout. Let's start with the environment. I just dropped a 3D model of a simple paintball arena into the scene. I've also added some items to the environment like a game object that has an audio source for background music. And as you can see in the bottom right corner, I have a Massive Loop spawn point where players will spawn into the world. For weapons, I have a few guns that the players can grab here and fire. Towards the back of the arena, I've placed these black rectangles, which are there to spawn new dummy targets. Each of these rectangles will spawn a dummy target at a random interval between 3 and 9 seconds. And there's also an invisible game manager object that controls some global properties like the player score that we want to keep track of. So let's take a look at exactly which scripts we'll need to program in order to build this game out. First, we'll need the gun.lua script, which is responsible for firing the gun and also the projectiles it's using. We'll also need a target dummy script, which is responsible for moving the target dummy, but also checking to see if the collider was hit by a bullet, so that we can destroy the dummy and raise the player's score. We need a target spawner, which will spawn target dummies at a random interval. And then last, we need the game manager script, which is responsible for keeping track of the player's score while the game is going on. So I made a backup of my working project, and I've cleared out all of the Lua scripts so that we can build them from scratch. You can see there's just a 3D model environment, there's an object that's playing an audio track, and then there's the canvas here that says pick up weapon, and that's all we have. To turn it into a Massive Loop world, I'm going to right-click in the hierarchy and select World Descriptor, and then add a spawn point and bind it to the world descriptor, like this. And then I moved it in place at the front of the scene. Now this has already turned the environment into a working Massive Loop world that we could upload and visit, but it's not a game and there's nothing dynamic happening here. I want to start scripting with the gun object because it's the most complicated object in our game, and also because it gives us an opportunity to use things like serialized fields, the getComponent method, events, and hopefully you'll see how familiar programming your world in Massive Loop Lua script is to what you're already used to with Unity. I have a gun prefab that I'm just going to drag into the scene here. It doesn't include any scripting yet, and if we expand it, we can see what it's made of. We have the gun mesh, the gun handle, which we'll use as the position to grab the gun, the barrel end, which we'll use as the position to fire the projectiles from. We have a basic particle system attached to a game object, and then we have an audio file for the gunfire sound attached to a game object, and then another sound for grabbing the gun and another for dropping the gun. To make this gun grabbable, we're going to select the root object, and then go to Add Component, Massive Loop, and select the Massive Loop SDK grab component. We have a few options here that are described in the SDK reference. I'm going to select Stick to Hand. so it stays in our hand and we don't have to continuously press the gripper to hold it. We also need to add at least one grab point. And I'm going to use the gun handle object as a transform for that grab point. Next, you'll notice that we have these events. The on trigger button event, which fires whenever we press the trigger button on our controller. The on grab begin, which fires whenever we grab the gun. And then the on grab end, which fires whenever we let go of the gun. We're going to bind a few methods to these events. So I'm going to add one, and I'm just going to drop the audio fire sound into the box and then select audio source play. This will play the fire sound whenever we press the trigger button. I'm going to do the same for grabbing the gun and dropping the gun with their own sounds. Now I can also add the particle system that we had in our list by dragging that object and selecting particle system play. And so now when we press the trigger, the gun will make a firing sound and it will also emit a particle system from the barrel. Next, we're going to create our script, gun.lua. To do that, I'm going to go to Add Component, Massive Loop, Lua Script. And we're going to select Create New Lua Script and give it a name. And press Create. I can double click on the script and it will open up in my editor. I'm using Visual Studio Code. So the do and the end define the beginning and the end of the script. We have a start method, just like we would in Unity, that runs once when the object is initialized. We have an update method, just like we would in Unity, that runs once every frame. We can reference the game object that this script is on, like this. And this can be really useful whenever we want to reference other components on the same game object. We're also going to need variables that reference our bullet prefab and the transform position that we want to fire bullets from on the gun. We can do this by creating two serialized fields. One for the bullet prefab and one for the object whose position we want to use. In this case, the empty game object that's positioned at the end of the barrel. Once we save the script, we can see that back in Unity, it has created two empty containers for our objects. So now we can just drag these objects into the fields. We're also going to need a variable that defines the speed of the bullet. Next, we're going to create the event that actually fires the bullet. I'm going to call it event fire bullet. In the event fire bullet, first I'm going to output the word fire. Next, I'm going to instantiate a new bullet using our serialized bullet prefab. After it's instantiated, I'm going to get the rigid body component of that new bullet using the getComponent method. Then I'm going to add velocity to the bullet using the speed that we defined here, making the bullet move forward. And I want the bullet to automatically destroy itself in 5 seconds, so I don't end up using up memory with bullets accumulating in the scene. You'll notice that I placed the definition for event fire bullet near the top of the script. The methods will need to be defined before they're called, so that's why I've written this event above the methods that will call it below. So now we have this event fire bullet, but it's not registered anywhere, so you can't actually call it yet. We can register this event by using the Lua events add local method. The last thing that we need to do is actually call this event whenever the trigger is pulled. We have a reference to the local object already right here, obj, and we can call other components on that object by using the getComponent method. So I'm going to call the SDK grab component that we dropped onto the object here. And I'm going to add another method called onGunShoot to its onTriggerButton event, so it will fire alongside these other methods. This onGunShoot method will simply invoke the event fireBullet event that we created here, firing the gun and sending the projectile forward. And that's all that we need to have a working gun. A couple of things are pretty cool about this script and worth mentioning. You'll notice that we register this event as add local. This means that the event is local just to this copy of the gun. So if we make other copies of it, then they will each fire independently, which is exactly what we want. Another cool thing is that this gun technically already works in multiplayer. First of all, the SDK grab component always synchronizes its events for all users. When we chose to use invoke local for all, this is basically saying fire this local event for all users that are connected to the world. You'll find a complete reference for all your options in using events on the complete SDK reference at sdk.massiveloop.com. We'll dive more into multiplayer in the next tutorial. Next, it's time to create the target spawner object. The target spawner object will spawn target dummies at random intervals for us to shoot in our game. First, I'm just going to create a new cube object. And position it at the back. Then I'm just going to drag this material on it so that it looks a little bit like a target dummy. And then I'm going to rename the object target spawner. And now we can create our script. I'm going to add component, select Massive Loop, Lua script, create new Lua script, target spawner, and click create. So let's start building out this script. First, we're going to get an object reference to the game object that the script is sitting on. We're going to create a serialized field that we can drop a target dummy prefab into so that it can spawn this prefab. We're going to define an initial time between spawns, but we're going to randomize that later. And then we're going to set the time since the last spawn to 0. Next, I'm going to create a spawn timer. The spawn timer function takes the time of the last spawn and increments it by the delta time. We can go ahead and print out the time that the last spawn occurred and also the time between spawns. And you'll notice I used Lua's toString function to wrap around the non-string values when we concatenate them to these strings. And finally, we look and see whether or not the time since the last spawn, which has been incrementing, is greater than or equal to the time between spawns. And if it is, then we go ahead and spawn the target. We're just going to run this spawn timer every frame by placing it in the update method. Next, we'll create a method to actually spawn the prefabs. This is the target spawner.spawn function. You can see that we get the position of the spawner. That's the position we want to spawn from. Next, we're going to instantiate a new target dummy. We're going to go ahead and have it destroy itself after 5 seconds so that we don't continuously accumulate target dummies in the scene and use up memory. We're going to initialize the time since last spawn, because we just spawned, to 0. And then we're going to randomize the time between spawns between 3 and 9 seconds. And that's all that we need for this target spawner script. We can go ahead and get rid of the start method because it's not necessary. When we save the script and return to Unity, we'll notice that we get another blank field that we can drop our target dummy prefab into. I have a prefab for the target dummy here, so I'm just going to go ahead and drop it into that field. The next thing we're going to want to do is go ahead and script the function of our target dummy so that it'll move forward and recognize when it's been hit. So I'm going to go ahead and click on the target dummy prefab, and we're going to add a component, a new Massive Loop Lua script. We're going to create a script called target dummy. We're going to define a few variables at the top of the script. First, we're going to get the local object, the local game object. Next, we're going to define how fast the target dummy is going to travel. Then we're going to create a dummy hit effect. So this object will instantiate whenever the dummy is hit, and it'll contain particle effects and other sound effects. The primary thing that we want to know about the dummy is whether or not it's been hit. And to do that, we can use the dummy's onTriggerEnter method from its collider. If we go back to Unity, to its prefab, we can see that it does have a box collider and that isTrigger is selected. The first thing that we're going to do is print out to the debug log that the trigger was entered, and also which object hit the trigger. And we might use that in the future as a filter to filter out objects that we care about. For example, if we only want to know if a bullet hit the dummy or another type of weapon. Next, we instantiate the hit effect, which is a prefab that just contains some particle effects and also some explosion sounds. And then we're going to destroy the hit effect in 2 seconds. And after that, we're going to destroy this dummy object because it was hit by a bullet and it should no longer be in the scene. Once the target is spawned into the scene by the target spawner, we're just going to translate it forward at the speed that we defined here. Again, we don't need the start method, so we can eliminate it if we like. And this is all that we require for the target dummy. When we save the script and return back to Unity, we'll see that we have the empty field for the dummy hit effect. I have one here. This dummy hit effect contains some basic particles and also an explosion sound. And I'm just going to drag this hit effect object onto the serialized field for the dummy to bind it. Now our target spawner and our target dummy are both complete. Finally, one last thing that we want to add to this game is a game manager object. The game manager is just an invisible object and is keeping track of global state for the game. I'm going to create an empty object and call it game manager. And then we're just going to go to the game manager and add a new script. There's a number of ways that we could connect to properties on the game manager object. We could define those properties as global. We could drop the game manager object onto a serialized field. In this case, what I'm going to do is set up an event on the game manager that we can call from other objects. In this simple game manager, we're going to keep track of the player's score. So I'm going to add a few properties at the top of the script. First, I'm going to get a reference to the local game object just in case I need it. Second, I'm going to create a player score property that we can use to keep track of the player's score as he destroys targets. Next, I'm going to define an event that we can call from other scripts called event add player score, where we can submit the number of points that he got for destroying a particular target. And all this is going to do is increment the player's score by the number of points. And we can go ahead and print this out to the debug log. In order to make this event work, we need to register it, and we do that in the start method. You'll notice that unlike the gun, where we use the add local method of Lua events, in this case we just said add, which creates a global event. It's not a local event to this object, instead it's a global event accessible from anywhere in the scene. I want to increment the player's score whenever the target dummy is destroyed. So in order to do that, I'm going to go back to my target dummy.lua, and I'm going to add this call to this event. Event add player score, and I'm going to give it a score of 10. So every time we destroy a target dummy, our score should increment by 10, send this event to the game manager, who will print out the new score. Just to finish up this environment, I'm going to make a few copies of the objects that we have. So I'm going to create a second gun here. And I'm going to duplicate the target spawner too, so that we have a few spawning on different rows. And that's it. That's all we need to do to create this game. Next, we would log into the Massive Loop control panel. We would go to the build tab, and we would either choose to build and run this locally if we're testing it, or if we're ready to upload it to the metaverse, we'll select build and upload. Naturally, as your scripts become more complex, you're probably wondering, how can I debug them? Well, when you build and run or build and upload, you can place the Massive Loop browser into a debug mode. And when you do, and it's running your world, it will communicate back to the Unity console here any script errors that have occurred. I didn't cover that today because I wanted to give you a general overview of scripting, but we'll include debugging as well as a really quick 5-minute tutorial on Lua in a supplemental video. Thanks for taking the time to watch this video. I hope you have fun experimenting with the SDK. I know this video is a little longer than the first two, but it does cover a lot of foundational information that you can use to script more complex environments and even complete games. In the next tutorial, tutorial number 4, we're going to start looking at how we can take this exact environment and convert it so that it works well in multiplayer scenarios, and change it from a first-person shooter into a multiplayer arena game. Have fun scripting, and I will catch you on the next tutorial.